let's study about Warshall algorithm today. Before moving on to Warshall algorithms, we need to know a little something called relaxing. Relaxing is a process used in Warshall algorithm to determine the shortest path to a graph. Let's take this matrix. The relaxing process occurs like this. First, we circle the first column and the first row. Then we select an element. Let me select 1, and we add the elements directly above and directly left to the selected item. So the directly above this element is 2 plus the directly left item is 0. 2 plus 0 is 2. If the addition of these two elements is less than this selected element, we replace this element by the addition of these two elements. Since 2 is obviously greater than 1, we do not replace that. So we move on to the second one. We take 5 and the directly above element is -1 and the directly left element is 0. So -1 plus 0 is -1. So -1 is less than 5. So the addition of these two is less than 5. So we replace that by 1. -1. Then we move on to the next element. Directly above is 2, left is 1, 1 plus 2 is 3, not less than -1. We move on to next. 2 directly above is -1, -1 plus 1, 0. So we replace 0 is less than 2, so we replace this by the addition of these two. We continue this matrix. So we already relaxed this matrix. So the second step is to circle out the second row and the second column. And we simply do the thing we did here. We select one element, then we select this, and directly right, directly next to it, and directly below. So 2 plus 0 is obviously 2, so it is greater than 1. We do not replace this. Then we take this side. For this side, selected element, the addition of element occurs with this side and this side, since it is directly next to it. So 2 plus -1 is 1. So it is greater than -1, so we do not replace that. So in here, the directly elements next to the 0 is -1 and -1. So -1 at -1 is -2. So we replace this. Since -2 is obviously less than 0, it is -2. And we take this element, the elements that are directly next to it are 0 and -1. 0 addition -1 is -1. Since -1 is less than 1, we replace it. Now on to the next. So the last step is we have used first column, first row, second column, second row, and here the last column, last column and the last row, which is the third column and the third row. And we do the same operation as before. When we take this, the selected element, this and these elements are directly next to it. So addition of -1 is -2. So we replace this with -2. Then we select this side. -1 and this -1 is directly next to it. So addition of 2 -1 is -2. Since -2 is less than this 2, we replace it. Then we take this element, -1, this -2. Same as when we take this element, it is also -2. So this is our final matrix, and this is the shortest path to a graph. Now let's discuss how the Warshall algorithm works. The Warshall algorithm obviously determines the shortest path between two nodes of a graph. These are called nodes or vertices, and these lines are known as edges or connections. I drew a matrix with these nodes. Now let's put necessary elements to it. As you can see, from A to C, the connection is 1, the value is 1. So A, C. We put 1 and next. C to B is minus 1. C to B. C, B. Minus 1. Then B to C. B to C is 3. Then B to A is 2. Then of course B to B is 6. That's all. Now to fill out the rest of the elements, we have some conditions to add here in the Warshall algorithm. And the first condition is, if there is no connection, if there is no edge between two nodes, we consider that it has an infinite edge. So in the graph, we have no connection from C to A. Even though we have a connection from A to C, we don't have one from C to A. So C, A. We consider that it has an infinite edge. The next one is we don't have an edge from A to B. We consider that also has an infinite edge. And the next one is, if a node doesn't have self-loop, value, we consider that the self-loop value is 0. So the B has a self-loop, C doesn't have self-loop, so we consider that as 0. And A doesn't have self-loop, we consider that as 0. And the last condition is, if between two nodes there are two edges going the same way with different values, we erase the higher value and keep the lower. Since in this example there is value 3 and 4, we erase the 4 and we keep 3. In this graph, we can see that from B to C there are two values, 3 and 4. We erase the higher value and keep the lower. Now we got the initial Warshall algorithm matrix. Now we need to relax this. Okay, now we have filled all the elements with the graph details in this initial matrix. Now let's relax this matrix. I've written the same matrix here. First step is we circle out the first column and the first row. Then we add the addition of an infinite with another element, or addition of an infinite with another infinite, always result in an infinite. So here we have to, for this element we have to add infinite and 2, which is infinite, and infinite is greater than this element, so we don't swap. In here 1, 2, addition of that equals 3, same value, so we don't need to swap. In here infinite, infinite. In here 1, infinite, it is greater than 0, so there's obviously nothing to change here. Now let's move to the next step. In the next step, we circle out the second row and the second column, and we add elements next to these elements. From 0, infinite plus 0, this is less. Addition of these two, this is less. Addition of these two is 1. So 1 is less than infinite, so we swap that. Addition of these two, 3, 2, we don't swap. Now on to the next step. Now let's move to the last and third step of relaxing. We circle out the third row and the third column. And we add elements next to selected elements. For 0, 1 plus 2 greater than 0. For this one, 1 minus 1 result in 0. 0 is less than infinite, so we swap that. For this one, 3 plus 1, 4, 4 is greater than 2. For this one, 3 minus 1 is 2, which is less than 6, so swap that. Now this is the final matrix, and by this we can decide the shortest path between nodes. For an example, let's take from B to A. From B to A, as you can see, B to A, we can see the value 2. So the matrix is correct. Now let's take a random value. From C to B, minus 1. It's also written here, minus 1. Now let's take another one, A to B. Here see, you can see A to B is 0. You can see the 0. Now let's determine how that works. To go to A to B, we can't directly go because there's no connection. We can go from A to C, then C to B. From A to C is 1 and C to B is minus 1. A to C is 1, C to B is minus 1, which result in 0. And it ultimately says that from A to B is 0. As you can see, the value is 0. Now that's how the algorithm works. Let's move on.
Now let's discuss the coding implementation of the Warshall algorithm. As you can see here, I have already inserted the Java code related to the Warshall algorithm. Let's look at that code a little bit. As you can see here, this is the number of vertices. This is the function to compute the transitive closure, which is the shortest path to the graph. This is to copy the initial adjacency matrix. And this is the Warshall algorithm's dynamic programming approach. And this is used to print the transitive closure matrix, which is the shortest path to a graph. And this is the function to print the matrix. And this is the main function, as you know. And this is an example graph that is provided by us to determine whether the code works correctly or not. And this is to compute the transitive closure. As mentioned earlier, this is to compute the shortest path of a graph. Now I already ran the code. As you can see here, the output is displayed, and this is the transitive closure matrix, and this is the shortest path to a graph between nodes. That's all for the coding part.
Now let's discuss the real-world applications of Warshall algorithm. The first one is network connectivity, finding if a computer in a network can communicate with another. The second one is road maps and navigation, determine if you can travel between two cities. And the third one is social media, identifying if two users are connected through mutual friends. And the last one is database query optimization, determining the relationships in a relational database. Those are the real-world applications of Warshall algorithm. Today we learned about fluid Warshall algorithm and how it operates, and the real-world applications of it, and the coding tutorials of that. If you want more coding tutorials like this, please make sure to like and subscribe. Thank you for watching. See you in the next video.